Very good. Multiply the numerator and denominator by 4 plus 2i, because you can't have an imaginary number in the denominator. So, FOIL the top and bottom. When you FOIL the bottom, you get 16 plus 8i minus 8i, which cancel, and minus 4i squared. And on the top, you get 12 plus 6i plus 16i plus 8i squared. What's I squared equal to? Very good. So on the bottom, that's 16 plus 4, which is 20. On the top, that's 12 minus 8, which is 4. Yes, ma'am. No, is there? Well, you can show me that in just a second. Let's go ahead and finish this. What would that be? Divide everything by 2. 2 plus 11i over 10. How do you do it on a calculator? Oh. Oh, hot diggity. And then it'll... Okay. Let's see. 3 plus 4i divided by 4 minus 2i. Let's see if it gives us 2 plus 11i over 10. Yep, 2 over 10 and 1, yeah, and 11i over 10. Haha. Wait, well, put it into fraction for me? Haha. Well, that's kind of, well, yeah, it just broke it up. 2 over 10 and 11i over 10. Nice. I did not know that. Of course, I'm now immediately going to take myself out of that because that's the only time today we're going to use that. But thank you for showing me. I did not know. Questions on the DOM? Let's get our review on. I am on page 381. The reason I'm not going all the way back to chapter 1 is that there's more stuff we can use the calculator for in chapter 2. And I'd like to look at that. We just did number 7. If you want to look at see what I'm going to, I went ahead and I pulled out like 9 problems total from this whole thing. So you're not going to be doing all the evens or anything. But I will do any 1 through 9, any of those odds you want to see. We did number 7. 1 through 9, is there another example someone wants to see? So pick one. Someone said 9. Okay, let's do 9. Number 9. What's the trick to this one? Take out the negative in the radical. That's right. So that's negative 2. What's the square root of 100? And what's the square root of a negative number? So that's 10i. And then we have to FOIL that, which means you don't just square both things in the middle. You have to write it next to each other itself and FOIL it. Negative 2 times negative 2. Negative 2 times positive 10i. Same exact thing. 10i times 10i. So that's 4 minus 100 is negative 96 minus 40i. And I believe that's as far as we can go. It is. I was just trying to show that when you multiply 10i times 10i, you have to square both the 10 and the I. Simplified, that's negative 100. I squared negative 1, 10 squared is 100. I beg your pardon? You can't, not unless it was over 2. I mean, if it had a denominator, you could. But this isn't like a ratio that you can just reduce. It's an actual answer. Sure. Surely I will. Do I need to leave this up there? This is approximately what the next 2 days are going to be. We're going to go through. I'll tell you the sections you need to look at. You'll tell me which ones you want to see. And then Wednesday we're going to have a pretest. Any final questions on this one? Where did we? We did. Well, we didn't square it. We FOILed. Negative 2 times negative 2 was positive 4. And then, yeah, you had to FOIL. Then outer and inner were these two steps. Any final questions? Number 1. When you subtract, what's the key? Yeah, distribute the negative and then just do your like terms, right? 8 minus 17. Negative 3i minus a negative 7i is negative 3i plus 7i. Yeah. That is often. Yes, it would. That's probably the most common mistake of all of math is overthinking. Questions over this one? Any of the others, 1 through 9 odd you'd like to see? We've done 7 and 1 and 9. So I get 3 or 5. Does somebody want to see number 3 and or 5? That's very thoughtful. I mean, I'll do them all, but we're going to go through 5 or 6 sections today, so. Well, just pick one if you want to see one. Oh. Well, yeah, those are pretty much the exact same as number 9, just without the I already. So no? Okay. Number 11 and 12. You solve each quadratic equation using the quadratic formula. Now, you should have done this till you were purple in the face. However, one of the things I'm going to show you today is how to use a calculator to find the zeros of a function. And why not start with this one? Because this one is an easy one that we can just find the zeros using the quadratic. But you can use what I'm about to show you on the calculator for any function, quadratic or not. So, let's practice with this one. First, let's do what it says. Quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. So that's 2 plus or minus the square root of negative 12. Yikes. Well, let's see. Negative 12 is this, well, that's not true. It's the same as I radical 4 radical 3. So would that be 2I radical 3? I'm sorry? No, it's a 1. It's 4AC, and A in this case was 1. Yes, that's the C value. So I guess all that would reduce to 1 plus or minus radical I radical 3. How many of these roots were real? None. Which is why you still need to know how to do this, even though I'm going to show you on a calculator. Because on the calculator, actually I won't bother with this one, because if you graphed it, it would show you that it's a parabola that never crosses the axis. But you'd still have to find what it equals. So that's why you still need to know how to do the quadratic formula. And I'm sure there's a way that you can get your calculator to tell you the imaginary roots, but I'll be darned if I know how to do it. Questions about how we solved for this? You want me to write the actual formula up there? Negative b plus or minus square root b squared minus 4ac all over 2a. You can use your unit circle and any notes you can squeeze on it for your midterm. Anybody have a question over this one? All right then, let's move on. Flip the page. Alright, 14 through 16. Use the vertex and the intercepts to sketch the graph. Give the equation for the parabola's axis. So, let's do number 15. Who can tell me how to find the vertex of a parabola? Over? That's right. Negative b over 2a. What would this one be? Just 1? Well, that's the x value. How do we find the y value? Plug it in. Very good. That's going to be negative 1 plus 2 plus 3. So 4. So 1 comma 4 is our vertex. What's the end behavior of this thing? Up or down, down? Down, down, because it's negative. Therefore, we're going to have a maximum or a minimum. That's right. What did it actually tell us again? Just sketch it. It says use the vertex and, yeah, and the roots. Now, negative b over 2a. Vertex formula is negative b over 2a. That's for the x value, and then to find the y, you plug it in. Now, again, you could find the roots using the quadratic, or, dun dun dun, the thing I'm going to show you today. And some of you may already know how to do this. Y equals, if you actually graph your function, squared plus 2x plus 3, graph. Now you could probably eyeball what values those are, but what if they were decimals? How could you find out? Well, I will show you. Everybody graph this function so we can do this together. I don't think I've shown you this before. Negative x squared plus 2x plus 3. Graph it, see. Hopefully you're looking at that. The St. Louis Arch. Alright. Is anybody having trouble getting that? Oh yeah, just if you're looking at just hit Zoom 6 and that'll put you at a base window. Zoom 6 puts you on a standard window. That's the fastest way to reset your window. Zoom 6. Okay, now hit second trace and it gives you all of these options. Now what are we looking for on this function? Are we looking for the zeros? The roots? So scroll down to 0 and hit enter. Now, the problem is, how many zeros does this function have? 2. It doesn't know which one you want. So that's why you have this cursor. It's saying, tell us, go to the left of the 0 you want and the right of the 0 you want so that we can narrow down our search. So we're going to take that little thing, we're going to scroll to the left of that 0 and hit enter. And we're going to scroll to the right of it and hit enter. And then we're going to skip the stupid guess feature. And it tells you, one of your zeros is negative 1. One of your roots is negative 1. The point of that, Bridget, was because the calculator can only give you one at a time. And it doesn't know which one to give you. So that's why it's going to ask you for a left bound and a right bound. And you're going to scroll to the left and right of one of your roots so that it knows what to look between to give you one. So you're taking this cursor and you're going to the left of it by just hitting the left arrow and hitting enter. Any point to the left, doesn't matter which one. Then you're going to go anywhere to the right of that 0 and hit enter again. Now it knows where to look between and it's going to tell you the 0 in between them. Let's try the other one. If it said no sign change, you didn't scroll far enough to the left or far enough to the right. Hit go to 0. Let's scroll that. Oh, there you go. That'll work. Enter. Let's scroll to the right. There you go. Enter again. Well, why'd you hit down? All right, go ahead and hit it. There you go. Okay, let's try the other one. Second trace 0. Let's find the other one. So we need to be somewhere to the left of that right dot or 0, somewhere to the right of that 0. Enter, and it'll tell you that the other one is positive 3. Positive 3. You can, but see, we're using this to start out. I'm about to give you one that's like the 5th power. Remember you had to do all that P over Q stuff? This will save you having to do that. This is just an entry level into this. But yeah, you could always use quadratic instead. Now, even though this problem didn't ask for the maximum or minimum, I think you can see you can use, guess which one we're going to use? Maximum. Not that this problem asks for it, but I think you can easily see, if they give you a function and ask you for the max or min, it'll be quite easy to see how you're going to find it. Go to the left of where you think the maximum is going to be. Go to the right of where you think the maximum is going to be, just like the zeros. And it'll tell you. Your maximum is at the coordinate 1, 4, which we already knew. If your calculator gives you a ridiculous decimal, it means you can round it. Then you didn't scroll to the left far enough or the right far enough. Did you hit minimum or maximum? Yeah. Also, if you ever try to trace a value and it gives you scientific notation, it's 0. Sometimes instead of 0, it'll be like 1e to the 4. That's just 0. Questions over this one? Of course, I think it actually asked you to graph it. But now we have all this information. We know that our roots are at 1 and 3. So to graph it, sorry, it was negative 1 and 3. Negative 1, 3, maximum at 1, 4. And you can graph your parabola. Now, a quick flash to the past. The reason I chose 15 and not 13, you could still do 13 the same way. Punch it into your calculator, whatever. But, what's going to be, what are the roots of number 13? Who remembers how to find that? Yes, negative 1. And how many of those do we have? 2. So it's going to touch at negative 1. Very good. Are there any questions on 13 and or 15 before we move on? Good. The only way this one differs is you have to give the domain and range and then the maximum or minimum value. So let's look at 17. Again, you do not have to use your calculator. We've already done all this without using it, but I'm just showing you time-saving ways that you can use it now. So let's look at 17. Part A, what's the max or min value? Which one are we going to have? Oh, raise your hand if you think you can tell me how you know we're going to have a max or min. Marco. That's right. In behavior was down, down. Therefore, that'll give us a what? A maximum. And, Amanda, how do we find that maximum? That's one thing you could do. Well, what's the formula we used a second ago? John, what was it again? Negative b over 2a, which would be 2 times negative 1, which is what, 7? That's the x value. Plug it in. Oh, let's see, negative a, was that negative 57? That's the one reason why graphing might not always be your best option, because there's no way in heck that thing's going to show up on your calculator unless you change your window. 7, negative 57 is our maximum. What's the domain and range of this going to be? Who can tell me what the domain is? What's the domain of any function you graph? Yes, ma'am. Yeah, which is going to be what on this one? All real numbers. Very good. And it'll always be all real unless you have something happening to it. But what about the range? How can we figure out the range? Very good. Very good. We know it's a parabola that has a peak to it, so you know it's going to go from negative infinity up until that y value, which we already found to be negative 57. So negative infinity and negative 57, parentheses bracket. If you tried to graph that, it wouldn't even show up on your calculator. Unless, again, you really finagled your window. Questions about anything that we did there? That's disappointing. Wait, about the domain, the range, the max, the min, anything? What's your specific question? To start from the beginning? Minimum or maximum? You're either going to have a minimum because you have a parabola, or a maximum because it's going down. Is ours going up or down? That's why we knew we had a maximum. That was the first thing we figured out. Your max or min on these quadratics, which is the only time I'll ever ask you for one, will happen at the vertex, which is the same exact thing we did last problem. You find that vertex by negative b over 2a, which is where this is, which is why it was this. Then we plugged it in and got the y value. So that was this. We knew we had a maximum at 7, negative 57. Now all we had to do is figure out the domain and the range. Well, the domain and range, the domain's always going to be negative, positive infinity. Unless, of course, you have a denominator, but we don't. So that was the easy part. All real numbers. However, the range, we had to use some logic. We knew it had a maximum, which means it looked something like this. So we knew the range was negative infinity up till that maximum value, which was the y value given right there. See, if it had a minimum, then let's say if this was a minimum value, then we know we'd go from negative 57 to infinity. So it's all about, are we going up or down after that vertex? Other questions? I think there's only 2 or 3 more sections I wanted to cover today. Let's see. Oh, we can do these together. 24 through 27. Remember, you could do it within behavior. Well, one thing we didn't talk about earlier was the degree will also tell you kind of how many swoops there are. So like, for instance, this one has 1, 2, 3, 4, 5. Which one of these has a degree of 5? Oh, well, sorry. They're in your book too. 26. Yeah. 25 has 6. So 1, 2, 3, 4, 5, 6. Of course, again, in behavior is probably the safest way to do those. But nonetheless, that was that one thing that I forgot to tell you about on the test and I omitted. That's how you do that. Questions about how you're going to identify in behavior, or I don't know. I can't really imagine you having one exactly like that. In fact, I didn't even give you a homework assignment like that. A problem, I mean. Let's see. I did, however, give you one like at the bottom of the page, which I have somehow skipped. Back. Zoom, 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 zoom. 35. Let's look at 35. You know, I don't know. I think it's 2.3 now. 35. Actually, let me check the whole thing. $35. Now, a second ago, I told you you could just go ahead and use the quadratic, and you still have that option. I mean, you don't have that option because now we're no longer dealing with the quadratic function, which is why I went ahead and showed you how to do it with your calculator. Now you can. Use the leading coefficient test to determine the end behavior, determine where, if it has any symmetry, boy, they're really missing some stuff. Because you also need to know your zeros in order to graph this with any kind of accuracy. Who could tell me how am I to find my end behavior? That's right. Use your end behavior chart. Odd exponent, positive coefficient. So what is that? Down, up. Very good. That's going to be our end behavior. Not that we can't just graph this on our calculator and take a gander at it. But are all the exponents odd or even or neither? Neither. You have a mix. Who remembers how to find the zeros if you don't You know, if you aren't given one. What's that? You could try grouping, and I think that would work. You could do P over Q list, also would work. Or you could do the same dang thing I told you about just a second ago and just graph it. Let's try that method. 2x cubed plus 3x squared minus 8x minus 12. Graph. Well, it looks like we have a double root and a cross root. Doesn't really matter which. We can find all of them, I guess. Second, trace. Let's find our zeros. Which one you want to find first? The one on the left or the right? Left. So let's keep scrolling until we're to the left of it. That looks about right. Enter. Scroll until you're at the right of it. Enter. And what value is that? What? Yes, it's a 0. Yes. Erica, what value is this? I'm underlining with my mouth. Yep. That's our 0. Negative 1.5. Now, Bridget, Stahl, what do we know about that 0? How many times does it occur? Or does it? What does the fact that it's touching the graph mean? Well, let's zoom in. Let's zoom in on that spot so we can see it more clearly. One second, Amanda. Oh, it actually does cross. My mistake. Not a double. So we need to find those two roots a little more effectively. Well, one of them was negative 1.5. So we can write that down. Negative 3/2. Yet another reason why it's not always great to use your calculator. And we need to find the other one. Of course, I have no idea which one we just found. I think we found the right one. Enter. Enter. And negative 2. So that's another one. When you graph these, well, never mind. Negative 2. Before I go any further, are there any questions about how we got those first two zeros? Again, okay. It's like this, Bridget. If I were to ask you, give me the 0 on the screen, okay? But I only want one of them. How do you know which one I want? Yes, but how many zeros are there on the screen right now? No, on my screen. How many are there? 2. Give me one. Give me the right one. Not the one on the right. Give me the correct one that I want. How do you know which one I want? You don't. Neither does the calculator. So that's why you have to. Oh, it went away. That's why you have to tell the calculator, which is why we're doing this. That's why when you hit 0, it says, okay, well, what do I look between? Now, it's like if I told you, now which 0 do I want? Now there's only one of them, right? And you would know which one to give me. So that's what we do to the calculator. We say, look between this number and this number with that little cursor thing. That's why you're scrolling. So, well, so you find whichever one you want to go for. Let's go for the left one, okay? You scroll anywhere to the left of that point, like right there. You hit enter. Now it says go to the right of that point. And I hit enter. And you can see it's like the 0 I'm looking for is between those. Now, you would get an error. Like, let's say your picture left bound here and your right bound here. You'd get an error because that didn't narrow down the search enough. It could still be either one of them. So that's why we do that. And then you skip the stupid guess feature, and it tells you your 0. Okay, good. Now, we still have a third one to find. So, zoom standard. We need to find that third one. Second trace, 0. We need to go to the left of it. Oh, whoa, too fast. Like there. To the right of it. And what was that, 2? Now again, yes, you could still factor by grouping. You could still do P over Q. You can still do all that stuff. I'm just showing you another way to do it. So we have our zeros. We have our lack of symmetry. We know our end behavior. And heck, we even have a rough sketch of what it's supposed to look like right there in the calculator. So you could sketch it. Cross at -2, cross at -1.5, and up to 2. Now, if you're wondering why both the ones we've graphed have had some kind of little special thing to them, like this one, I assumed that was a double touch right there because I couldn't see any closer. They did that because it was my job to teach you how to do it without a calculator. So they gave you problems like this that could be potentially misleading. That way, if you tried to use a calculator, not that I'd even let you anyway, you would have been misled. So that's why that happened. Questions about anything we just did? Or what you're going to be asked to do? Great! Let's see, I only had 1 or 2 more. We have 3 chapters to review before Thursday. And we're only getting half of one done today, so bear with it. Alright. You have to do long division and synthetic. I do believe all the rest of the ones I have set aside are of that variety. So, do you want to see a long division and or synthetic problem? I heard of both. So let's just do one of both. I'll do 43 and 45. Zoom, 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 zoom. 43. I don't think there's a way to do this on the calculator, but I've been wrong many times. Long division. Am I missing any terms here? Am I missing any terms? I should have. In fact, I'm glad you pointed that out because I was like, man, that's going to be a pain. Okay, well, I mean, it would have. We would have just had a fraction, which would have been annoying. Okay. Senior Robbins. Where do I start? That's right. And how many times is that? That's perfect. 2x squared times. Multiply it back through. 2x squared times 2x squared is 4x to the full. 2x squared times 1. What do I do now? Subtract. Put a parentheses around so you remember to distribute that minus. Cancels. This guy just falls all the way through. And minus 2x squared. Okay. Jalen, what do I do now? You can, that's true. Six x cubed divided by 2x squared, 3x. Multiply that back through. 6x cubed plus 3x. So, cancel. This falls all the way through. 0 minus 1. See? Negative 2x squared divided by 2x squared. Negative 1. Multiply that through. Negative 2x squared minus 1. Hot diggity. What kind of remainder are we going to have? Nada. Which means we are happy. If you had a remainder, what would you do with it? You're all saying the right thing. Very good. You add it. You would add it at the end. So, like, let's say we had a remainder of 7. You would put plus 7 over your original divisor. But we didn't, so I'm going to erase it. What were you saying? What do you mean, how can we? Because there was nothing to subtract it by. It was negative 2x squared minus nothing. So we just brought it all the way down. Yeah. That's the same reason we did it up here, too. 6x cubed minus no common term. Whenever you're dividing, that's an excellent question. Whenever you're dividing with a missing term divisor, you're going to have little gaps like that where things are going to fall through. In fact, I think we did one in the past where it was like x cubed and this is 1 and there was like 2 gaps every time. So that's going to happen. Other questions? And I think we had a request for a synthetic division problem, and then that should wrap us up. Working. But then what are we doing? Alright, Latifah, what goes up in my little synthetic box? Very good. Bridget Stahl, fill in my numbers for me. Nice. Oh, just kidding. You were right and I was wrong. Good thing you guys are here. I'd be wrong all the time. Okay, drop the 3, multiply, add, multiply, add, multiply, add, multiply. We have a remainder. Oh no. So, who can tell me what my depressed polynomial is? Third, not 2 to the third. Go on. Very good. Just like a remainder in log division, you just tack it over the original divisor. While some people are writing that down, I'm going to put your assignment for today on the board. I'm going to write it in this little box here. No. Nine problems. I don't really care how you do them. You can use an old method. You can use a new method. Completely up to you. Good question. Title this. Excellent, excellent question. But we're going to do that tomorrow. Yeah, we'll still go with that. Chapter 2 review. C2R. Chapter 2 review. So I should give you a rap song. These days. These days. You're not nearly old enough to say these days.